Great. We now have our next speakers who are regular attendees of this meetup. So really appreciate people stepping up to do talks. And we need more speakers, so let's get into who would like to talk at this meetup. So without further delay, the next topic is securing sensitive data in logs like a pro by Vivek Ragunathan and Bahul Jain. Over to you guys.
That's not the topic of the talk. Yeah. Just testing the slides. No. All right, that's the topic, securing sensitive data in logs like a pro. As Salah introduced, I'm Vivek. I go by High Phenotype Online. I also write a blog. That's my co-speaker. Did you take a bow? That's Bahul Jain. So what's the problem? So our applications log, a lot of data, and it's important for observability and debugging. And what happens is that applications end up writing sensitive data to logs. For instance, we work in the healthcare domain where PHI and PI is of vital importance. We get audited every year or every few months. So we need to make sure that whatever data goes in the logs is not sensitive and it's not in plain text. And I mean, of course, as you know, the things like this lead to data breaches and compliance and regulatory issues. The recommended approach is to redact sensitive data, and we'll see how we're going to do that. Some of the existing solutions, as you might have seen, is they use like key value pairs where the key says what type of field it is, but there's a problem with that. A key may be called by any name. I guess you can see user ID may be user underscore ID or UID or whatever, right? And then you maintain a huge dictionary of keys, and you match against that. It's not going to scale, and you don't get the control in the application domain, like what and how needs to be logged. If you have an object, you just end up logging everything with these key value pairs, and there's no guarantee of what you're logging. You don't have control at compile time. I mean, you can do a log.info, and then you will see what happened at runtime. So, and then there are some solutions that are out of band, as in like you look at these logs and try to see if there is PI in it and try to redact it, which is out of band solutions. What we are going to discuss today is something that we can do at compile time. And next slide, we call the process sanitization, which is a way of getting the string representation of a certain piece of data. And we call the piece of code that does sanitization is called a sanitizer. And the library that we're going to discuss now is called a sanitizer. Let's go here and just flipping between the windows. So these are the design goals. We want type-based sanitization. We want compile time guarantees. We want to keep sanitization and logging as orthogonal concerns. And we want minimal boilerplate and familiar API, as in like we still want to use our logger.info and logger.debug. We don't want to deviate from that. Some logging related best practices. Just all right. As always, we start with a type class. We call it a sanitizer, and it has a sanitized method. And what it returns is sanitized. So sanitized means, okay, it's good to log. Whatever sanitization needs to be done has been done, so it's good to relog. That's how a sanitized looks like. I know it's a little, I can't.
I'm old and I can see it.
Okay. All right. So the sanitized has an apply method, which is going to be helpful when instantiating it. And then it has two methods like tokenize and raw. So tokenize is the one that a way of reducting or a way of hashing, whatever your implementation is. And raw is the raw text. It's okay to log in plain text. So that's how we start with sanitize.
Can you explain that again? The tokenize is what?
Tokenize is a way to say that this is sensitive data. So I want to either redact it or I want to hash it. It's implementation dependent. You can hash it or redact it, depending on how you want to implement it.
Oh, so if you hash it, it goes in the log files as a hash.
Yes.
And then you can look it
Yes.
up. Oh, that's okay.
And then continuing with the sanitize, we do have an implicit conversion, which given a type using the sanitizer will give you a sanitized version of it. And we have syntactical helpers here. Again, they're same tokenize and raw, but it's used for the type class when you deal with the syntax thing. Coming back to sanitizer, we have certain same defaults here. Like for a string, the sanitized version of an opaque string is, a tokenized version of it because you don't know what's going to be in the string. For Boolean, it's okay. You can do a raw, and we do have sanitizers for collections and other types like UUID or whatever your domain needs, right? That's that. And then
So can I ask a question? Is raw just
a two-string
like a
version.
two-string?
Yeah.
Okay.
We didn't want to go as far as, again, introducing a show for it, so it's a simple two-string. Okay. And then we write the straight logger one time. It matches the SL4J interface. It's the boring boilerplate, but it's one time. It just has a couple of things. It gives you the context, the name and the line, file name and the line numbers. And then the message is a version of safe, which is like that. So the format spec for a logger where you say, with all the format specifiers, that's been encoded as safe to distinguish from sanitized. And the safe also gives you the interpolator. We just use uppercase S. The regular string interpolator we have is the lowercase s, so we just want to match with that. So that's the uppercase S. So when you pass in your format spec and the parameters are going to be converted into sanitized, and that's what gets logged. And in order to get to convert to sanitize, you need a sanitizer, which is what this implicit conversion here does. All right. All right. Once we put it all together, that's what it's going to look like. Your famous logger.info, the only difference would be your uppercase s instead of a lowercase s. You can interpolate, regular strings and ints and whatnot, or you can also interpolate person object, for instance. So what happens here is it's going to look for a sanitizer, which is an implementation of the sanitizer that we saw earlier, which has a sanitize method, and it's going to use that to sanitize it.
Here's the sanitizer of what type?
Here it's person, here it's string and int.
I see.
And this is how it would look like for a person class. You have complete control over the parts of, or the fields of person, like how it has to be logged. So I can say, I want to tokenize the name, but I don't want to tokenize the age or whatever, depending on what fields you want. You can even ignore them. It's up to you. I'm going to stop there and hand the baton to Bahul to see some advanced features of how not to write sanitizers, automatically derive them.
Any questions so far?
Yeah.
Yeah, so one question. So basically, I don't have compile time safety here, right? If I make a mistake and do logger.info and convert the person to string, that would compile. So I have to make sure that I really use the string interpolation with a capital S. So I mean, I could grab the code for small s string interpolation or missing string interpolation, but so I wonder if there's a way to get more compiled in case I forget it.
So in the real case, we do have rules where you have to use our logger. So if you use some other logger, it's a compile time error saying, we use scala style to enforce that.
Okay.
And the other thing is, if you try to log a person, and you don't have a sanitizer for that, it's going to complain. It's going to be a compile error.
It's looking for implicit instance of
And
course
because
of
I'm
sanitizer.
using your logger, that's,
Yeah.
yes, I get it. Thanks. This
Yeah.
helps. Yes, thanks. Yes.
Okay, so just looking at this, can you guys just tell me what you guys don't like about this?
Uh,
There's a bunch of things I can think of.
Can you derive the sanitizer for me?
Sorry?
Can you derive the sanitizer for me?
Yes, that's one of those things. I don't want to write this ugly looking string for every object that I'm creating, right? That's one important thing. The other thing is that, formatting. I don't want to have ugly formatted a string, like the data objects in my logs. Like I want them to look in a certain way all the time, right? So that's usually where the derivation comes in, right? Another thing that, that might be a problem here is that we mentioned that there is a default sanitizer for strings, right? But not all strings are necessarily sensitive information. And similarly, dates, right? Dates can mean different things. Birth date is sensitive, but something else, some other kind of a date cannot be sensitive. So these are the things that, are not handled really well. So as I said, right, too much boilerplate, strings are very non-uniform. It's really hard to maintain because, every time you add a new field to the class, you have to now also update the sanitizer. So you have to add that extra line. And if you can easily forget that. So, you might just miss that out. As I said, it's not exactly accurate for primitive types, strings, temporal types, they can be anything. And finally, a redundancy. So if you have two objects, two classes with first name, and in one class I can define first name as sensitive and the other one I can say first name non-sensitive. So it really causes conflicts in different areas. So you want to be able to control this from one location.
why is it inaccurate for primitive types? Why?
As I said, right, strings, right? For example, you have first name that's sensitive, that's PII, but somebody's Twitter handle, which is it's public information, but that's also a string. So you can't really tell.
Oh, I see.
We have defined a default behavior, so like covering, like just to be safe, we are saying all strings are sensitive, but they need not necessarily be. So yeah, you want to be able to define it based on the type itself.
Is there any thought to allowing the user to specify the sensitivity of the data and have that propagate?
Yeah, I mean, that's what I will come to. Yes, but that's my point, right? That every type should have its own sensitivity, and that should be defined.
I didn't necessarily mean by type. I meant by a specific instance of the data. Say.
Right. That's yeah. So basically, right, for an instance, right, for a string, it's not easy to say that, but there are different. You can actually define a value type instead, and that way you can define it on that. So that's what we will explore further. All right. So this is something what we would ideally like, right? So given this particular object, I want this kind of an output, right? Without having to specify the whether each one of these types is sensitive or not all the time, right? Especially when we are defining the sanitizer for person. I don't want to bother with mentioning what this is, whether this is sensitive, this is not sensitive, right? Those are like boilerplates, redundant stuff. And I want the output to come out to be in this particular uniform structure. So this is where we come to, so we'll go through a bunch of these concepts. I'm hoping most of you guys know this, but if you don't, please let me know. Just, raise your hand, ask questions. So the first thing is derivation. And just by show of hands, how many of you guys know Shapeless library? Most of you guys, right? It's pretty popular.
Yeah, but I haven't used it for a very long time.
Oh, you haven't? Right. So I won't go into the details of Shapeless, but essentially it lets you deconstruct a particular class into a generic representation where you have this class which is a string, which comprises of a string, an int, and a string, and it converts that into a heterogeneous list which has those types, right, in that order. So now it's given this structure, it's easy for us to kind of apply the sanitization for every individual type and then kind of do a map and then kind of collect or fold kind of an operation on this. And that's what we have done here basically. So we basically deconstruct the type to its generic representation with shapeless. That's part of the library. And here for every type we are ensuring that there is a sanitizer available for the head of the list and for the tail of the list, and apply that sanitizer to each and every individual type.
So can I ask, you're throwing away the information that this is a person? You only have the attributes of the person, but not the information that this belongs to a person?
Why would you need that? I mean,
I'm just asking. So
yes. So basically, it's an algebraic data type. It's constituted of different types, right? It's a product of different types.
yes.
And when we are logging the individual types. We are not actually logging anything related.
So for the logging context, it's not important
Yes.
that this is actually person data.
Correct.
But, okay.
I mean, the only thing about the person we are logging is the name of the class, right? So just person and then followed by all of its
okay.
constituent
I see. Okay.
parameters.
Okay.
Is there a reason to even log the data at all? I mean, I can't see how person star 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 is actually going to tell
Well,
you much.
We don't know, right? A person can have fields that like internal identifiers that we want to log, and then there are some fields which are PII and PHI. We don't want to log those. So that's the idea here. And I get your point, right? Your point is that why bother logging the whole object? Instead, just log what you need from that object. And that's true, right? That's what you should do ideally. But this allows us to kind of prevent that even if people log the entire object, it won't log the sensitive information. It'll only log what is non-sensitive.
I think the answer to your question is you may want to log the hash of the name.
Yes,
something
and that's
like that,
important.
so you can tie in together different log lines.
Correct.
Yeah.
That's a good point, right? That's exactly why we are hashing. You can also have for like a lookup table for the hash if you want to store them and then give that access to only a few set of users, right? So that mapping can also be.
Is it a one-way hash then?
Yes.
Oh, okay.
Your system doesn't detect what needs to be redacted, or you got to know up front.
That's
what
the
you need to
idea.
redact,
Yes.
right?
That's the idea. Yes. And while you're coding, while you're creating a domain model, at that point itself, you say this is PII. Just anywhere in the code where or anywhere in the logs this is being logged, and it has to be redacted. And the same idea goes for some types. I won't go too much into this. Pretty much the same. You basically go through all possible subclasses and match it to whichever it is passed, and make sure that there is an implicit sanitizer for that. If it is found, then your code will compile. If it's not found, it will just throw an error, compilation error. So at the end of this, you end up with something like this, right? So now your sanitizer is just something like sanitizer.derive, and you could actually even further simplify it by just creating a macro that appends this piece of code at the end of your class and replace this entire block with just one simple annotation called @sanitize, right? Just keeping your boilerplate minimum.
How does it know?
No,
Go ahead. I was just curious, how does it know what to do with the UUID when I say .derive?
Right. So as we said before, right, there were certain types that we defined default behavior for.
Okay.
Right. So this is going to be defined in the sanitizer, the companion class of sanitizer. So any defaults we define there, they will be picked up automatically.
Can you say what the defaults are for UUID, string, and int?
Yes. So for UUID, it's because it's an identifier, where default is to tokenize it. For strings, we tokenize it. Ints, we do not tokenize. And for string, and then I think we have few more defaults like temporal types, which we are not tokenizing. again, this really is context specific, and it's probably not even good to have these defaults defined, right?
It's a weird choice. I mean, my age is kind of PII.
Exactly, right?
Yeah.
So I
But
understand what
UID
you're
in many
saying,
cases, you
and
can't really trace that.
I personally am not a fan of having defaults because, you know, as I said, right, it could be context specific, right?
Mhm.
So
Like it goes against
But
what you're trying to say.
correct. So that's the thing, right? Maybe even int should be what we should probably do if we want to do define defaults, right? We should be a bit more restrictive. So if UUID can be PII, let's just put it as tokenized. Or if a string can be PII, let's just put it as just tokenize it. And similarly for int and string, I agree with you, right? Ints can be PII, PHI, we should tokenize it.
So is there a way for me to opt in? Like I say, okay, name in that case, I want it, that string, I know it's actually safe.
Right.
That other string, I want the default behavior that would be.
Right. So that's the next part we'll get to. But yep, hopefully this part is clear that we've gotten rid of significant chunk of boilerplate. We are able to derive it. We are able to create a uniform string every time. And most importantly, it's easy to maintain because now every time you add a new field or you delete a field or you change your class, the sanitizer is automatically derived for you, right? This is the one problem that we keep talking about, context agnostic types, right? So strings, ints, temporal types, all these primitive types, we don't know what behavior we want to use. So there's one way we could do this, which is field annotation, right? We add this ugly little annotation. I don't know if you guys will like this, but I find this ugly. But we could do this, right? Add an annotation in front of the field itself and say what's the policy, right? So yeah, in this case, we are saying this is a string. The default behavior of string is to tokenize it, but here we are adding an explicit override policy, which is that this is going to be raw, and then everything else looks the same. This is one way we could do this. So for that, we have to define an annotation, and we have to tweak our derivation method to take this annotation, like to extract these annotations and then use it as a part of the derivation. This is a tricky part because we are extracting the annotation is pretty straightforward. We just pull the primary constructor of the particular class, get the parameter list, and then extract the annotation for every field, for every parameter. And we return essentially a map of the field name and the sanitization policy that's associated with it. This is some reflection code. Now, this is where it gets a little tricky. You have this map which contains the annotations associated with every field, but you want to be able to use that as a part of your derivation logic, right? Though the derivation logic is dependent on the type itself, right? So that we define, we derive based on the type, right? And we can't pass this as the field sanitization, the policies that we are defining, that map we are defining, we can't pass it as an argument, right? Because, well, it has to derive that based on the type. So what we do is we create this tuple, which is basically up here, right? So we look for a sanitizer where we have the generic representation and the sanitization policy, that map we've created, right? And we create a tuple out of it, and we look for an implicit sanitizer for this type now. And so we've tweaked our this derivation method, the one which we were deriving for the heterogeneous list. Now every element is basically we append the field sanitization policies or the map that we have. It's appended to the every type. So now each type or each element of the heterogeneous list contains that field sanitization policy as a part of it. And then then here if we pass it when we call the sanitize method, that time if we pass it, it interprets the correct type. So that takes care of our field annotations is one way where we can deal with different sanitation behavior for the same for context agnostic type, like primitives, right? But I don't like that, right? Because again, I can have two separate classes, both of them have first name, but in one of the class I say first name is tokenized, and the other one I say it's raw. So that's conflicting, can cause issues, right? So the solution to that is to use opaque types, right? That's the best solution we have, like, which is using opaque types, value classes, tag types, whatever you want to call it, right? Pretty easy to implement in Scala, and we have some good libraries that give you tag types as well. So with that, now you can associate the behavior to that actual type, and this will ensure that wherever this particular value type is being used or value class is being used, the sanitization behavior is the same, right? This takes care of that. Any questions?
I'm sorry, maybe I'm blind, but I don't see where the opaque type.
Right, so
what is opaque here?
opaque types is a concept of Scala 3.
Right.
Right.
So
I haven't
don't-
given an example here.
Because it's opaque.
Yeah.
Because it's, no, I'm just joking. It's what you say is opaque type, what do you call it? Twitter handle
Yeah.
equals string. And then I forget, except in that file, that it's a string anymore. So it comes out as a different type, so I can apply a different
Okay.
sanitizer.
Exactly.
Okay.
Basically, yeah, you're defining types for everything. Nothing is a string, nothing is an int, nothing is Boolean. Everything is a type, and it's its own type. So you can assign custom sanitation behavior to every particular type, and that's how we deal with. We get rid of context agnostic issues. Right? That takes care of that. And finally, I do want to talk about protobuf sanitization. Here we have something called as descriptors. For folks who have used protobufs, you can add descriptors to every field. Just like how we added field annotations, you can do the same thing with protobuf field annotations as well. And when this code gets compiled and generated, the field annotation is present in that generated file. So it gets added to these Scala descriptors, like that's what they call it. And for each field, you can get the options, or in protobuf they call it extensions. Instead of annotations, they call it extensions. And so you can obtain the extensions from the descriptor of that particular field. And then, of course, your derivation would pass, again, when we generate the extension, when you extract the extension, we would convert it into that same format where we had that map of the field and the sanitization policy. So the same logic we can reuse for protobuf sanitization. And that's it. Any questions? So with this, the idea was to have a very minimalist way to sanitize all of our code without having to go around and creating new toStrings or toShows or all these kinds of methods, and make sure that we adhere to compliance and regulations, where we were held back by this huge client who was like, we will not enter into a contract with you guys if you guys are pushing logs, sensitive information in logs. So this was something we came up. There are some barriers to, there are some negatives to this. One is that yes, you have to actually go in your code and define the sanitizer for each and every class that you use. Otherwise your code will just not compile. Right? That's one big thing. The other thing is using shapeless. I guess most of you must know using shapeless has its drawbacks. It can cause compilation slowness and give some funky errors when things are not working. It's hard to decipher what goes on, what's going wrong. But so far, yes, these two have been our biggest challenges with this particular library, but it's been working well so far. Yeah.
I have a question, which is when I actually want to look in the log file and figure something out, is it I mean, do I have trouble sometimes with hashes that I can't figure out what was going on? I mean, I guess how helpful is the log mess when you're actually trying to use the log for figuring out a debugging a
Correct.
problem?
Correct. So yeah, there's a couple of thoughts to that, right? In my opinion, if you are logging something, there should be traces, right? We should be using traces more to debug issues instead of using PII and PHI information. That's one thing. Second thing is that so we actually implemented this third API called tokenize and save, right? What that does is it generates a hash, a one-way hash, and we also save that one-way hash along with the API information in some sync. And somebody with super user access or like admin access can actually look that up. But it's not a recommended approach because it can really flood your database or whatever storage you're using with. If people are not careful with how they use the API, they can abuse it, and all of a sudden you'll find that your database is just blown out of proportion. So that's another thing you can do. But my recommendation is to not use PII for tracking issues, right? That's the best thing I can say.
I mean, just for troubleshooting, you don't need the real value, right? As long as you even have the hash, let's say it's the hash of the user ID, it's going to be the same all across. We want to de-anonymize.
Oh yeah, same. Okay, I can see it showing up all these different places.
Yeah.
Oh yeah, okay.
There are some applications where you want to know the PII because think of something like registration. Every registration failure is specific to that user, which is where we call it token sync, where you save the PII hash versus PII, and only certain users can figure out like what the hash means, because we want to troubleshoot the registration failure for that user.
There's one drawback to using one-way hashes is that it cannot prevent access patterns from being scraped, right? Because you're using the same hash value across your logs, anyone could still capture those logs and scrape for access patterns, though they won't know who that user is. But that's still invaluable information.
Yeah, and then the way to beat around that is again, the PSA is a can of worms, right? And it's not like you do one thing and it's solved. You have to keep at it you have to iterate on it. So one way that's being implemented is to key rotation, right? The hash that you use once every few, whatever the cadence is, you rotate the key so that you actually kind of muddy the patterns.
Yeah.
So some measures there.
Have you considered removing the default sanitizers?
I would love to.
Yeah, I mean, to me, that's the only.
Yeah,
I would be convinced of the approach only.
No, you can make it defaulted hashes it.
Yeah, that's what.
No, actually, I don't think that's a good default either.
Oh, okay.
Exactly for the reason that you
make
gave.
an opaque type.
Yeah, like you have to be explicit about it.
Yeah,
Right.
ideally we should remove it. In our domain, we just have it as the last measure. But ideally, I mean, this is not like open source or anything yet. But let's say open source it, there should be no defaults. You have to be specific about how you want to log it.
There was a reason why we introduced defaults, because in our
All your colleagues hated you?
Sorry?
All your colleagues hated you because they had to annotate everything?
Yes, that's one. Like basically, they adopt this library and code just starts breaking everywhere.
Yeah.
Right. So that was the reason we.
Well, you want to be secure on that.
Would any of your customers have considered a more drastic solution, such as sending the PII into a vault, getting back a token, letting all of your infrastructure pass the token along, and then if you needed to access the token for some reason, access the actual value, going back to a vault?
Really? And again, this is only in the context of logging, right? Your other data stores have raw PII, and it's okay to have that because there are different levels of access control. So what you mentioned is probably applicable for permanent data stores, but not in the context of logs.
I mean, this library is mainly trying to prevent PII in just logs.
Logs.
That's the main goal here. So behind the scenes, you can create a hash using some hash function, or you can exchange it with a vault. You can do whatever you want. That's on the
This isn't
implementation.
securing the PII in a database or.
No, it's not about that. It's just that it should not be exposed in logs. That's the main thing.
Because a lot many people have access to logs than to that your
Correct.
application database, right? The production database.
Yeah, the vault solution is often used in a circumstance where I have to, send a database password. I don't want to put it in clear, so I send it to.
It's a safe to string because you actually ship the logs to something else.
Yeah.
Have you thought about how this would manifest itself in an API description? So if you were to use something like OpenAPI or something where you describe your fields, I noticed since you have the protobuf, you have the opportunity to put the descriptors in there. But I'm thinking protobuf is not really the level that I would assume many people would look at, but maybe for an API description.
So you're talking about if I use OpenAPI, how do I?
Or RAML or any of these things where they basically work closer to maybe a JSON level or something. You somehow indicate that this is the PI. The PII marker goes here, and then your system automatically picks up.
I don't know if there is something like that OpenAPI supports. But on the other hand, you still have the flexibility to define the sanitizer for the OpenAPI model. And you can still, if you want, you can annotate it with whatever each field has to do.
Yeah, at the end of the day, the type is actually not the right place to do that. It's the field.
Yeah.
That's why protobuf is actually much better because you can talk about the field and you don't have the wrong proxy using the type.
I also have a high-level question. So, as I understand your system, you created a type-safe solution where basically the developers decide how to sanitize which data type, the policies. Could there be a requirement where that decision, how to sanitize what, is not done by the developers, but actually has to be decided by a lawyer or so? So I'm thinking of parallel here, like the Java security model. There you have a .properties file, basically a text file, and there you can fine grain level specify the sandboxing of the JVM, which directory may it access, which files and which not. So basically, you would lose compile safety, but basically you would have your code as is, and you would have a rules file or text file or something, and that would be responsibility of lawyers. And the developers would just have to tell them, I have a person data type, and I have an address data type, and I have these data types. You decide, so what is sensitive and what is not. So if you had this flexibility, I'm thinking about testing, also prototyping. You could have isolated test systems where you wouldn't have to sanitize anything. So you would just change a properties file, and then for production system, you would then use the correct rules-based file that would tell you how to send it. So you would lose compile safety, but you would gain flexibility on the decision what to sanitize how. Yeah.
That's the first thing he had mentioned, right? We use some sort of a key value based, like a rule system.
Okay.
Right?
Yeah. Yes.
Exactly.
Yes,
that's
yes,
what he said.
yes.
But the biggest challenge with that is how will, like, for example, a lawyer know what are the different fields that you're using, what types you're using, right? And in the code, it could be user underscore ID or user, in Camel case, user ID or UUID.
Okay.
Like, it leaves a lot of, it's very vague. It's not very easy to make it concrete.
Yeah.
Right? That's the problem with that approach. We actually did consider that approach as well.
And the lawyer would say sanitize everything. So yeah.
So we have like a privacy department. So when you go to them and ask like, hey, can we log this? Don't log in.
Yeah.
okay, yes, okay.
We sorry, just one thing. So we do have rules that we have internally maintained, right, which we keep verifying with the lawyers. Usually it's just like probably like 30 or 40 or 50 fields, right, that are generally considered PI or PHI. And we keep that synced with the lawyers. And then within the code, if you're defining a type, like again, it's hard to implement that kind of a check, right? But that's what we do internally to maintain that.
So you showed the protobuf. Are you deriving the Scala classes from the protobuf definitions or the other way around?
So the protobuf is where you define the model, right? And then the compiler will generate, the protobuf compiler will generate the Scala files, the class files.
So you start with the data model outside of Scala.
Correct.
So you can actually generate the Scala code that is safe.
Correct. Exactly.
Okay, yeah, I think that's something you should mention in your talk because that's very important.
So I have a question about enforcement of this.
Right.
Like what approach can we use to verify that only this type of login actually used, like maybe at compile time or at runtime, like to prevent, for example, occasional like acid out or like alternative logging.
Sorry, can you repeat the question again?
So the question is, we know how can we verify that any type of login in our domain actually used through sanitization and not, for example, like occasional maybe std out in different places or third-party libraries that maybe perform their own login and can expose.
So what we have used is Scala style to enforce that. Like for instance, if you have used, let's say, plain SLF4J or system.out or something like that, then it's a compilation error.
Mm-hmm.
So you need to, if you have to log, you need to use our log.
Any approaches for third-party libraries that can do their own logging?
You could. I mean, Scala, we use Scala style, but I think the better option would be Scala fix, so that you have more control over like.
Are you talking about like a different logging library or
yeah.
Like let's say third-party library you're using and it just throw in tested out like some stuff. Like
it's more out of band, as in like outside the library. You just have to enforce that. So like Scala style is one way.
You might be able to use a Java agent. Aspect.js like things you can route std out to another place. Like
I mean, the possibilities are limitless. We have to cover. It's hard to cover everything, but Scala style, Scala fix is one of the ways you can try to cover a base.
I have a PII question. Isn't Twitter handle I could figure out who somebody is? Is that's not personally? What is the P? Is it personally identifiable information, or is it private? Or
It's
personal.
Because Twitter handle, if like I'm trying to keep a secret who this is, it's just saying a Twitter handle would be.
Pretty
easy to figure out who it
it
is.
depends on the use case. Yeah. No, sometimes it will be considered PI, sometimes.
Yeah.
Okay. Have you looked at the Python T-string and compared your capital S interpolator to the T-string at all?
Sorry, I have no idea what that is.
The capital S interpolator you
Right.
use, that looks very similar to the Python 3.14 or 3.13 feature with T-strings.
Okay.
It gives you an opportunity to basically take a string, render it into an object, and then you can use a reflective like post-processing of the object to decide what, the final language.
Scala has this. That's the Scala feature.
Right. I was thinking the S, the capital S, it could be used. Well, any logic you come up with for your capital S interpolator, I could see a use in Python as well.
Right.
It's like to the degree
Same
that.
idea.
A question. So once you force people to make opaque types in the Scala 2 flavor, do people feel like that makes their code better because it's not stringly typed anymore? I mean, just forget about sanitization, but just like you have you're kind of forcing everybody to make specific types. Maybe I was thinking might make the code better.
Yeah.
In general.
Yeah.
Do they
And
do they feel it's like a pain and they kind of like it, or?
so, well, in my team specifically, I can't speak for my whole company, but in my team, we do like it that it is all opaque types, right? Because it kind of it's not just sanitization, right? Any other type specific behavior, right? It all gets defined at the definition level, right? Where you're defining the domain model, and then everywhere else in your code you can just derive logic, right? So in my team, we have seen tremendous benefits of using opaque type definitions everywhere. Really makes our code more readable, simplified, and a very, very, very important benefit is that AI generated code is always more accurate because there's less to generate.
I mean, to answer your question, whether you like it or not, you have to, you'll end up defining these value types because you will end up in a situation where you want to do something with the certain field in a certain context and you don't want to do it there. So only value types come to the rescue.
I mean, in a world like that, you become incentivized to reuse the types that are defined in one place because they come with the sanitization. So that's good.
And there are libraries, I mean, within the company. So a lot of the types that people want are already defined. So they're not going to do everything from scratch. Like if there is like an order system or something, they might have to define their order IDs and things like that. But user IDs are all already defined.
Right.
So there's opportunity for reuse.
Actually, that might be a good way to make someone else control the behavior of every type, right? Maybe have someone else own that library where you're defining the type and its sanitization behavior, and that way you could keep the control away from the developer and instead to somebody else, right?
Yeah, I was going to mention that instead of having defaults, you could have just an explicit import,
right?
Where people actually would do that. So it would fail by default, but say, yeah, you can be more precise about what you actually need.
Right.
One more question. Since you're using protobuf, do you use it only for data exchange, or do you have several other modules written in other languages? You don't use it as a language, both.
Yeah.
But then you have to have the same problem in other language that you have to do some sanitization. Yes. Okay.
We did implement it for Java. I didn't want to mention it.
For Java.
Yeah.
For Java, yeah, but it's all runtime.
It's horrible.
It's all runtime, as in like, if you try to, the same concept of the sanitizer still holds, but you don't have this much, I mean, you do have granular control, but you don't have contextual granular control.
Yeah.
So if you define a sanitizer for person, that's it. You don't have different, but if you don't have a sanitizer for some types, it just automatically redirects it. So it's very restricted in what you can do.
Yep.
But the end effect, you get the same end effect, so it's okay.
Yeah.
I mean, that's the best you could do with Java.
Yeah.
It reminds of how good Scala is, yeah? How they had both eyes.
This is a very good example of where Scala shines.
Yeah.
Shines really bright.
A very elegant solution. Really liked it.
I mean, you have some Java Scala interop, so you could make Java code call that Scala. Okay, you don't want to go there. Yeah.
No, I don't want to go.
Yeah.
There are dependencies that bring in the whole
Yes,
Scala ecosystem in there.
Yes, I see. Yeah, try HList in Scala in Java. Okay.
Great. Thank you for such a great talk.
Thank you everyone for coming. Thank you, Bill, for your talk. Thank you for hosting us.
Thank you.
Please do it again. Thank you all. Have a good rest of the evening, and let me know if any of you want to meet up in the future. Also.